Hello and welcome. When the Wright brothers demonstrated their heavier-than-air controllable aircraft, navigation wasn't a worry. These were local flights around the field. As aircraft developed, they were able to fly away beyond the field. How then to navigate, either back home or to a destination? Well, the same as ships have for centuries, using a compass and a watch. A compass would allow flight in predictable directions to a destination. We all know that compasses consist of magnetised needles that react to the Earth's magnetic field, pointing north and south. Degrees or angles from here could then be read. Just how is it that the Earth has a magnetic field? I mean, it is not there just to serve pilots or sailors. If the Earth didn't possess a magnetic field, life wouldn't exist here. The Sun emits a plasma of radiation into space in a solar wind that sweeps over the Earth. This radiation consists of charged particles, including heavy ions and atomic nuclei, travelling at varying speeds of up to 750 kilometers per second. The Earth's magnetic field is able to deflect most of these charged particles. Without the magnetic shield, the solar wind would strip Earth's atmosphere of the ozone layer that protects life from harmful ultraviolet radiation. It is just as well that the International Space Station orbits Earth inside our planet's protective magnetic field and is heavily shielded. For the time they are in space, most astronauts receive radiation equivalent to radiation that 10 X-rays would deliver. For career airline pilots who might spend 30 to 40 years flying above 30,000 feet, the story is different. They will receive significant radiation over a lifetime. So back to what is it that makes the Earth a magnet? Our Earth is composed of a solid iron and nickel core which has a radius of about 1,220 kilometers, about 20% of the Earth's radius. Here the temperature is about 5,430 degrees C, the temperature of the surface of the Sun. The inner core is considered a plasma, behaving though as a solid. The magnetism of iron is altered when temperatures are so high and the atoms can no longer align to a magnetic point. All known planets have metal cores, even the gas giants such as Jupiter and Saturn. The Earth's outer core, about 2,200 kilometers thick, is a liquid composed of iron and nickel and has a temperature of about 8,132 degrees C and has a low viscosity. This makes it easily deformed and malleable. Earth's outer core is a geodynamo. Heat from the inner core drives convection. Variations in rotation, conductivity and heat impact the magnetic field of a geodynamo. Earth is considered a Goldilocks geodynamo. It rotates steadily at a brisk 1,675 kilometers per hour at the equator. Coriolis forces, an artifact of Earth's rotation, cause convection currents to be spiral. The liquid iron in the outer core is an excellent electrical conductor and creates the electrical currents that drive the magnetic field. Adding to these effects are the tidal forces caused by the Sun and Moon, just as they affect the oceans on the surface. Although Earth's magnetic field is generally stable, it does fluctuate constantly. As the liquid outer core moves, for instance, it can change the location of magnetic north and magnetic south poles. The magnetic north pole moves up to 64 kilometers every year. Fluctuations in the core can cause Earth's magnetic field to change dramatically. Geomagnetic pole reversals, for instance, happen about every 200 to 300,000 years. These pole flips are not catastrophic. Scientists have noted no real changes in plant or animal life, glacial activity or volcanic eruptions during previous geomagnetic pole reversals. The Earth's mantle is 2,900 kilometres thick and makes up about 67% of the mass of the Earth. Although solid over geologic time, it behaves as a viscous fluid like caramel. Lithostatic pressure keeps the mantle in a solid state even though temperatures of 4,000 degrees C at the core boundary would melt the material. Reading compasses in aircraft is not what it used to be. The reliability of systems employing GPS makes a compass almost redundant, even when the poles do swap. Thank you for watching. Comment if you will. Like, subscribe, and hit the notify bell.